subscribe.
Hey y'all, welcome back. Today we are going to start reviewing a bunch of algebraic topics that are going to be really fundamental to your success next year in calculus. So we're going to start off today just talking about linear functions, and then next time we'll talk about quadratic, and then we'll kind of move on from there. And really our focus is going to be primarily on solving equations, although we'll also be analyzing some of these functions as we go. So for this first day, like I said, we're just looking at linear functions and all the kinds of things that go on in regards to that. So these first kinds of problems that we're going to answer are going to be trying to find the slope of a linear function. So whenever you're trying to calculate the slope is commonly notated using the letter m. And the way we calculate them is, the way I like to think about it is like the change in y over the change in x. Okay, so I know this is, there's no spaces here, but what I'm going to do is actually change the word change here to use the Greek letter delta. And this Greek letter delta is commonly used to notate change. So change in y over the change in x. In other words, how does the y change with respect to how does the x change? So when we go to calculate the slope, we're given 2 points, and these are going to be just 2 points on the grid. So you can sort of imagine like 3, -4 would be like somewhere down here, -9, 11 somewhere down here. So we've got this slope, and we want to compute the actual slope of the line. And so the slope, what it does is it describes how steep the line is. So the steeper it is, the further away your slope is going to be from 0. If the slope is going up from left to right, if it's increasing, your slope will be positive. And if it's decreasing, if it's going down from left to right, it'll be negative. So when we go to calculate the slope, we really just want to be looking at the change in values here. So these are my y. The y coordinates are the numbers that come second. And so my change in y is going to be the change that I have from -4 to 11. So one way to think about it is like, you want to think, what do I need to add or subtract to get from -4 to 11? Okay, so to get from -4 to 11, I need to add 15. Okay, so that's my change in y here. So my change in y, or my delta y, is positive 15. And that's because I need to add 15 to get from -4 to 11. My change in x here, from 3 to -9, I would have to subtract, let's see, what would it be? I'd have to subtract 12. So my change in x is going to be 12, -12 rather. And we should be expecting a negative slope going back to like my quick sketch here. It is going down from left to right, so we should expect a negative slope. So my overall slope here is going to be the change in y over the change in x, so that's going to be 15 over -12. And when we reduce that by dividing both of these by, 3, you would get -5 over 4. And so that would be our slope here. For the second example here, we can kind of do the same thing, where we find our change in y and change of x here. So in this case, my change in y, to get from 10 to -13, would be -23. And my change in x would be from 8 to 8, it's 0. Okay, I don't have to add anything. So my slope here will be -23 over 0. And as you may remember, we can't divide by 0, right? So this is just going to be undefined. Now, how that is interpreted graphically is if you have 2 points like this that are going to be aligned vertically, so like 8, 10 is going to be somewhere over here, and then 8, -13 would be down here. When you have a vertical line, it is said to have no slope for this very reason, right? We can't divide by 0, so we call it undefined. So there's just no slope here. It's not considered to have any slope. So it would be okay to just say no slope as well, or you could just say that the slope is undefined. For the last example here, we're dealing with some fractions here. So sometimes, when you're just dealing with integers, it's kind of easy to figure out what your change is. But it's not so obvious when you've got fractions, I think. I think it's a little tougher to just sort of figure it out. Yeah, I might just redraw this. I don't really like how that's turning out. So one other way that you can interpret this change in y, like going back to this one where we found it was 15, one way that you can compute the actual change is by just simply finding the difference between the two values. So like here, if I did 11 minus negative 4, I would get 15. If I do negative 9 over 3, minus 3, I would get negative 12. So another way that we can sort of interpret this slope, instead of thinking about it as change in y over change of x, which is, I think, still easier if the numbers are nice. But if they're fractions like this, another way to think about it is to just subtract the y values and subtract the x values. So sometimes you'll see this formula written as y sub 2, let's see if I can do a little subscript here, y sub 2 minus y sub 1 divided by x sub 2, like the second x value, in other words, minus the first x value. There we go. So in this case, it's probably going to be easier to figure out the slope by using this explicit formula here, and then just plugging in everything where it belongs. So let's see what we have here. So we have the slope. It's going to be this y2 minus y1 over x2 minus x1, where y2 is going to be the second y coordinate, this 2/5. The first y coordinate is also 2/5. So actually, this one's going to work out pretty nicely. We almost don't even have to do all the arithmetic here. So x2 is going to be negative 7 over 11th, and then the first one is 3/2. So, at this point, you typically need to go through. Find a common denominator and add or subtract these together. But no, look at the top here. We got 2/5 minus 2/5. We know that's going to be 0. So I'll spare you the arithmetic here. You don't really need to calculate it. All we really need to know is that it's not 0, because this whole thing is just going to equal 0. Not sure why it's not letting me type 0 here. There we go. So the slope here is 0. But yeah, if you were to actually subtract these two, just for practice sake, you would first need to find a common denominator, which would be 22. So this would be like 14 over 22, and if I multiply that by 11, that'd be 33 over 22. So we would get, what would that be? Negative 14 minus 33 would be negative 47 over 22. You don't really need to know that here, like I said, because we know it's going to be 0. But if, just for fun, it would be this. So yeah, our slope here is 0. Now, whenever you get a slope of 0, what that is indicating is that the points are horizontally aligned. So here, just to do a real rough sketch here, 3/2, 2/5 is going to be roughly here. Negative 7 over 11, comma 2/5 is going to be here, and we can see that these points are aligned horizontally. So when they're aligned horizontally, the slope will always be 0, just like how if the points are aligned vertically, the slope will always be undefined. So that's how you find the slope given 2 points. This next section is going to be asking us to write the equation of the line in the specified form. Looks like point-slope form, given these different requirements. Now, just as a little reminder here, point-slope form is going to be y minus y1 equals m times x minus x1. So when you write your equation, the x and the y will just remain x and y. But what you're going to be doing is plugging in values for m and for x1 and y1. So yeah, here the slope is going to be m. So we'll either have to calculate that or it'll be given. And then x1, y1 represents just some point on the line. And usually that point is given. Like in this case, it's negative 9, 11. But sometimes you're given 2 points and you can kind of pick either one. So this is just any point on the line. So for this one, we're trying to write an equation in point-slope form, so we're not going to have to like convert it or anything. So we're just going to set up our little template here. Our x1, y1 is the negative 9, 11. So my x1 is negative 9, and my y1 is 11. So I'm just going to plug that in here. So you want to be careful here because it is x minus x1. So when you do x minus negative 9, this whenever you subtract a negative, we can interpret that as just addition. So y minus y1 would be y minus 11. Our slope is 3 over 7, and that's it. So we would just leave it like this. Now, in some cases, I might ask you to go ahead and rewrite this in slope-intercept form, which we haven't talked about yet here, but which is written as y equals mx plus b. And if I were to ask you to do that, the way you would get there is to multiply the 3/7 over and then add 11, and then you'd have it. So there's 2a. B, so here's our x1, y1, here's our slope. Yep, let's grab our little template here. And so our slope here is 7/8. Our x1 is 8/3, so doing some fractions here, and my y1 is 0, so that's kind of nice. So in this case, we're trying to write our equation in standard form, so we need to know what standard form is. So standard form is just, a slightly different way of writing these linear equations. The format here is going to be ax plus by equals c. And the only catch here is that a, b, and c need to be integers. Okay, so like whole numbers. Or in other words, just no fractions. So we're going to have to deal with that fraction, these fractions in our equation. So the way to get it into this form, notice that the constant here is what's isolated. So let me just kind of walk you through these steps. First thing we want to do is we're going to distribute the 7/8. So y minus 0 is just y. So right now I have y equals 7/8 x minus, 7 times 8 would be 56 over 24. So you get a pretty lovely fraction here. At this point, I'm going to try to clear my fractions. So what I want to do is basically multiply the entire equation by some number that's going to clear the fractions out. And what it should be is the least common multiple of all these denominators. So it's like when you have to add or subtract fractions, you try to find a common denominator. It's the same kind of idea here. So what I'm going to do is just multiply everything by 24. And that should, so multiply the left-hand side and the entire right-hand side. So I'm basically using this property of equality to clear my fractions out. So after multiplying that 24, I get 24y equals, I want to be careful here, so let's see, 24 divided by 8 would be 3. So 24 divided by 8 would be 3, times 7 would be 21, so I get 21x minus, and then the 24 over 24 here will just reduce to 1, so minus 56. So our goal here is to get this constant isolated, get our x and our y on the same side. So the last, I left a y out there. Last thing to do here is going to be to subtract that 21x over from both sides. So I get negative 21x plus 24y equals negative 56. And that'll be our equation in standard form, okay? I know some textbooks will say that the leading term has to be positive. I don't know, I mean, some don't, so it's okay if you leave this negative, as far as I'm concerned. Okay, so that's standard form. Let's try one more example here, except we've got kind of a crazy looking point here. And it says m is undefined. So I want you to think about what that means. So if we're just going to sketch a graph, earlier we said that when a line is undefined, that means that it is a vertical line. So if here's my x and y axis, and I've got some point out here which is going to correlate to this coordinate, and if the m is undefined, what that means is that I have a vertical line. Okay, so I'm going to draw a vertical line, okay? And then the way to write, because you can't really write an equation that has an undefined slope in, like slope-intercept form or point-slope form. But anytime you have a vertical line, think about how we wrote the equations of vertical asymptotes. It was always like x equals something, right? And that is how you write these vertical lines. So in this case, it'd be x equals, and then whatever the x-coordinate of the point that's on the line is. So in this case, 15/19. Now, if I want to write this in standard form, I do need to clear those fractions out. So I'm going to multiply both sides by 19, and I get this. There is kind of like a plus 0y here, which you don't really need. So I'm just going to leave that out. Quite honestly, I'm okay with either of these. It's kind of weird to write an equation like this in quote-unquote standard form. I kind of like this one up here better, but that's not what the directions ask for. So we'll just leave it like that. Now, just to kind of bring this to the next level, now we're going to start writing an equation of a line that passes through two given points. So here we'll actually have to find the slope first, and then we'll start writing the equation. So this one says it intersects at the x-axis. Now, the y-axis at y equals 8. So that means we're going to have a point at 0, 8. And then the other point, which is implied here, is we're crossing the x-axis at -6. So that would be -6, 0. So let's go ahead and calculate our slope here, which remember is change in y over change in x. Just copy that up here. And so yeah, let's figure out our change in y and change in x. So our change in y here to go from 8 to 0 would be -8. So again, if you're trying to approach it from the perspective of using that equation, it would be 0 minus 8, which is -8. -6 minus 0 would be -6. So if you're just thinking about it in terms of change, the way to get from 0 to -6 is going to be to subtract 6. So when we simplify this, we get positive 4/3. So that's my slope. And so let's go ahead and write our equation. This one doesn't specify what form, so I'm just going to go with slope-intercept form, or point-slope form, rather. Not sure what happened there. Okay. There we go. So the slope here is 4/3. And then the x1, y1 can actually be either one of these 2 points. So just to kind of stay on the safe side, I will typically, if I have an option of 2 coordinates, is to pick the one that kind of seems simpler or the one that's has everything is positive. That way I don't have to worry about subtracting a negative and remembering that that's going to be plus. So here my x1 would be 0, my y1 would be 8, and I can clean that up a little bit. Get rid of that minus 0, and get y minus 8 equals 4/3 x. If you were to write it in point slope or slope-intercept form, which is that y equals mx plus b form, it'd be 4/3 x plus 8. So any of these choices is fine. This would be sort of the classic point-slope form. This would be slope-intercept form. So this next one is going to be worked out just kind of the same way. We need to calculate the slope first, but we actually already did this one. We did this back on 1C. I think it's the same coordinate. Is it the same coordinates or no? 3/2, 2/5. Okay, so that one's the same. And -7/11, 2/5. Yeah. And so what we found on this one was that the slope was 0. So we're going to have a horizontal line. So anytime we have a horizontal line, the equation, just like with our horizontal asymptotes from the last unit, are going to be written as y equals and then whatever the y value is. So since the y value here is 2/5 in both cases, we can just write this as y equals 2/5. So we don't even have to really, we calculated the slope earlier, we found the slope was 0. And so yeah, there's the equation of that line. So in this next section, we're going to try to figure out where the x and y intercepts are before we graph and then we'll use those intercepts to help us graph. Although we'll kind of go back and forth here. So to find the x and y intercepts, we need to understand what's going on the graph at those points. So any points that lie along the x-axis will be the x-intercepts, and all the points along there have a y-coordinate of 0. So I'm going to make a little note here that x-intercepts have a y-coordinate that equals 0. And similarly, the points that lie along the y-axis, or the y-intercepts, they'll all have x values that are 0. So y-intercepts have an x-coordinate that equals 0. Okay, so this little fact is going to help us find these intercepts. And so basically what you do is, for the x-intercepts, you'll plug in 0 for y and then solve for x, and then just do the reverse to find the y-intercepts. So we'll start here with the x-intercept. To find the x-intercept, we're going to set the y-coordinate, or the y value, equal to 0. There we go. Try to get that on there. Okay. So yeah, we'll have 10x minus 12 times 0 equals 60. So to get x here, 12 times 0 is just going to be 0. So we'll just have 10x equals 60. Oh, whoa, we don't need all that. And then, so dividing both sides by 10 will result in x equals 6. So our x-intercept here is going to be 6, comma 0. Resize this box. There we go. All right, so to find the y-intercept, we'll do kind of the same thing, except we'll plug in x. We're putting in 0 for x. So to find the y-intercept, we are going to substitute in 0 for x instead of y. So our 10 times 0 minus 12 times y equals 60. So 10 times 0 is obviously just 0, so we have negative 12y equals 60. And if we divide both sides by negative 12, we get y equals negative 5. So the y-intercept here would be 0, comma negative 5. So with these intercepts, we can use these to actually graph the function without having to put it into y equals mx plus b form or anything like that. So we'll start with the x-intercept, which is at 6, 0. So that's going to be right here. I'm trying to do a little dot here. Oh, okay. Something like that. And then the y-intercept's at negative 5. And then once you have those 2 points, you could just sort of play connect the dots here and draw your line. Okay. Yeah, so there's that one. The next one, x equals negative 7. Now, we've talked about this already. When you have x equals a number, that's just going to be a vertical line that crosses through the x-intercept of negative 7 here. So we really don't have to do any work here. We're going to say that the x-intercept is going to be negative 7. And because it's a vertical line, it's never going to cross the y-axis. So there will be no y-intercept. Now, as far as what the graph looks like here, really you just need to plot the x-intercept, the negative 7, comma 0. So negative 7 is going to be right here. And we should have a vertical line. Well, should be pretty vertical. I think I'm a little off here, but that's okay. And then for the last one, y equals 4, that's the equation of a horizontal line that passes through the y-intercept of 4. Okay, so kind of similar to the last one, except instead of there being no y-intercept, in this case, there's no x-intercept. So we'll go ahead and say that there's no x-intercept, and our y-intercept is going to be 4, so 0, comma 4. And we'll plot that kind of similar to the last one, where we will start with a a point. In this case, we'll start at the y-intercept of 4, which is right here. And then it should be a horizontal line here. Okay, so there's all 3 lines. So just wanted to show you that you can find the x and y intercepts and use that to graph rather than having to rewrite it into any other form to get it. For these x and y equals equations, those are just going to be vertical and horizontal lines respectively. So there's not really much to say about those. All right, so number 5, we're going to be changing one variable's value, and we're going to say, okay, well, like if for 5a, we're saying if y increases by 9 units, what's the corresponding change in x? So the first thing we want to do is try to find the slope here, and we are going to use a form that I've been referring to that you're probably aware of, called slope-intercept form, which is y equals mx plus b. So if you just look at this equation quickly, it may look like it's already in that form, but you'll see that it's actually x equals rather than y equals. So our first step is going to be to get this into y equals mx plus b form. And we'll do that by using our properties of equality. So we have x equals 5/6 y minus 11/4. So the first thing we'll do is add 11/4 to both sides to move that term over. And the next step is going to be to get rid of this 5/6. So we're going to divide both sides by 6/5, or another way to think about that is to multiply both sides by 6/5. So it's like we're going to multiply this side by 6/5 and also this side. So we'll get y equals 6/5 x. Oh, I'm not sure why we switched over to blue there. Let's fix that. There we go. Y equals 6/5 x plus 66/20. And don't worry about reducing this. It'd be 33/10, but it's not really necessary. So what we found here is the rate of change here, that delta y over delta x, or that change in y over change of x, which is 6/5. So I'm going to just grab this real quick. There we go. So our rate of change here is 6/5. Right, and this is saying if y changes by 9, what is the corresponding change in x? So basically what they're giving us is the delta y here, the change in y. So this is going to be our change in y, and they're asking us for the change in x. So the change in x, that's going to be our delta x. So the change in y is going to be 9. And we're going to find the change in x.
I have a pass waiting down in the box. Can I grab it? Thank you.
So we'll use the cross products property here. We're going to cross multiply and get 9 times 5, which is 45, equals 6 times delta x. Not all that. There we go. And so the last step here is going to be to divide both sides by 6. So we get our change in x. The corresponding change in x is going to be 45/6, which should reduce, let's see, we divide all that stuff by 3. We should get 15 halves. Okay, so that's going to be our answer here. The corresponding change in x is 7.5. Part B here is asking about what's the corresponding change in y if we know what the change in x is. It's using the same equation, so we don't need to find the slope again. The slope here, or the change in y over change in x, is going to be 6/5 still. But what is given is the change in x. So the change in x here is 7, and we're looking for the change in y. So we can use the cross products property here again, or we could just multiply both sides by 7, and we'll get the change in y equals 7 times 6 would be 42, so 42/5, and I don't think we can reduce that. So that'll be our answer for that one. So basically, if you, oh, you know what? I missed something. Decreased by 7 units. So really, this should be negative 7. And so the corresponding, it should be a decrease of 42 fifths. So it should go down by that much. Okay, so the last thing we're going to review here today is how to solve a system of equations. And there are several different methods that you can use to solve these, but I'm going to primarily use the method of substitution, which is where you take one equation, substitute it into the other, and then solve for that variable, use that to find the first variable. So, so let's go through, there's just a couple of examples here, and I'll show you how this is done. So for this first one, we already have one of the equations with y isolated. So what we're going to do is we're going to take this expression here and substitute it into y into the other equation. And that's going to give us the equation 3x plus 2 times negative 3 halves x plus 2, which is what we're substituting in for y, equals 5. And then we start to simplify this. So I'll start by just using the distributive property here. So I'll get negative 3x plus 4 equals 5. And take a look at this. 3x minus 3x is going to be 0. So when that cancels out like that, we'll be left with just like one number equals another. And if that's true, then you're going to say that there are infinitely many solutions. But if it's false, like this, then we say that there is no solution. And basically the implication here is that you have two equations that are parallel. Okay, so basically our answer here is going to be no solution.
He like comes back to his eyes are like bloodshot red.
There you go. All right, so that one we didn't really get to go through the whole process here, so let's take a look at B. All right, so this one doesn't actually have any variables isolated here, so you just need to pick one and kind of go for it. So I'm gonna try to solve for this y right here. So let's start by subtracting 5x from both sides. Okay, so if I subtract 5x from both sides, I'll get negative y equals 2 minus 5x. And if I divide all of that by negative 1 to isolate the y, I'll get y equals 5x minus 2. So that is an equation, or an expression rather, that I can take and substitute into y for the other equation. So this method is called substitution. Just a little reminder. That's why it's called substitution. So we get 3x minus 2 times 5x minus 2 equals negative 3. And now we're just going to use the distributive property and our properties of equalities to solve this linear equation. So if I distribute the negative 2, I get negative 10x plus 4. And I need to combine my like terms. So I get 3x minus 10x is negative 7x. So negative 7x plus 4 equals negative 3. If I subtract 4 from both sides, I'm going to get, oh, this is going to work out nicely. Look at this. Negative 7x equals negative 7. So x will equal 1. So yeah, so there's, so this is x. Now this isn't our final answer, so I'm actually not going to box that yet. What I need to do is use this to go and find y. The solution to these systems are the coordinates where the two lines intersect. So I'm really looking for an ordered pair here, an x and a y. And what I can do is substitute again and take this 1, substitute it into this equation to get y. So y equals 5 times 1 minus 2. So 5 times 1 is 5, minus 2 is 3. So I get my y coordinate. And finally, I can write my ordered pair here. It's 1, 3. And that's going to be the solution to this system. They got the x and the y. All right, so we got one more here that we'll go through. In this case, it looks like the y in the second equation is going to be the easiest thing to isolate here, because all I'll have to do is just divide everything by 4. So I'm going to rewrite this equation over here as y equals 6 over 4 x plus 8 over 4, and I can reduce those to be 3 halves x and 2. So now I can take that expression, just like on the previous problems, and substitute that in right here. So I'm going to get 3x minus 2 times, something weird is going to go on with this one too, I can already tell. equals negative 4. I'm still going to just go through my algebraic steps here. I'm going to start by distributing the negative 2. So I get 3x minus 3x minus 4 equals negative 4. And so something similar to the first problem occurs here where all of our x's will sort of annihilate each other. But in this time we get a true statement, right? Negative 4 does equal negative 4. So this is a little bit different than the first one where we ended up with a false statement. So if we get a true statement, then we'll say that there are infinitely many solutions here. And that will be how we answer that. It's not to say that every ordered pair is a solution, but there are just infinitely many of them. There's also, ordered pairs that are not solutions. So, but we'll say there's infinitely many solutions.
Let's go.
All right, well, that's pretty much it for today. Let me know if you guys have any questions. I know we're just kind of reviewing today, so I doubt there's going to be too many questions because you've been working on this for the past couple of years. So, but let me know if you do have questions. And other than that, y'all have a great day, and I'll see you next time.